Rack and stack, installing network switches. By the time we're done here, you will understand core switch functions, selection, and installation process. To track where we're at on our journey, our cables are now tested and we're ready to install the switch to provide network connectivity in the office. Now it's still going to look a little messy, and I want to give the neat freaks among us some hope. Don't worry, in the next nugget we'll be doing the cable management installation and things will start to look good. Now, before we get to the point of installing the switch, I want to make sure that we all understand what this device actually does. A switch is a successor to a hub, meaning it's a second generation product. Its goal is to provide intelligent, and I threw in there layer 2, I'll talk about that in just a second, network connectivity. Up till now, we've been talking about patch panels, which are great devices to terminate cables, meaning we now have a cable run that moves from a wall jack or a ceiling port, or wherever in our office, to a central place in the MDF. But outside of providing a port, the patch panel doesn't actually do anything. The switch is where the functionality is provided. So in order to achieve network connectivity, we have to connect those patch panel ports, thus all the ports in our office, into the switch. You see a whole glob of ports right here from the patch panel to the top switch, a whole glob of ports right here from this patch panel down to this switch. The switch itself can do all kinds of stuff, and I've sifted it down to 3 core functions right here. Number 1, it provides a speedy transport. Now, the definition of speedy has evolved over the years. Decades ago, it was 10 megabits per second. That was the original Ethernet standard. Around the turn of the century, it evolved to 100 megabits per second, and that stayed for a long time. As a matter of fact, there's still a lot of 100 megabit per second ports connecting offices together. But the modern standard is 1,000 megabits per second or gigabit per second down to the desktop. Being that most devices use somewhere between 1 to 20 megabits per second when doing normal day-to-day functions like surfing the internet, watching YouTube, basic file sharing, that should give plenty of room for growth. You really see that bandwidth being used when you do high volume tasks such as video editing over a network or large file transfers. And it's very common to see servers utilizing that level of bandwidth because you have a bunch of clients accessing them at the same time. The second core function is to learn MAC addresses, and thus my note on providing intelligent network connectivity. Back in the day when we had hubs, which looked exactly like switches, this device simply repeated the signal everywhere. Where this computer would want to send some information to the server, or the server want to send some information back to the computer, and the hub would just send that information everywhere. Every device plugged in would actually get the sending and receiving. It would just ignore it because it would realize by looking at the addressing that that data wasn't intended to be received by that device. It's definitely not good for security nor scalability. The more devices you add to that hub, the slower and slower it gets. Switches actually learn the MAC address of the device. Every computer, every server, everything that connects to a network has a MAC address built into its network card. The MAC address is often referred to as the physical address. And if I type in the command ipconfig/all on my Windows 10 computer right here and scroll back up to my network card, I'm able to see that this LAN adapter has the physical address F8B156, etc., etc., etc. You can see the rest right there. It's a 12-character hexadecimal. That means A through F are valid characters as well. Value that's literally burned into this network card. As the computers and the servers and everything else on the network communicate, this switch learns where all those addresses are located. And that allows it to intelligently filter. Meaning when this happy computer down here sends to this server, that switch knows exactly where the server is and sends the data directly between those two, rather than bothering everybody else on the network with it. Last note on that, I said it's called a MAC address, it's called a physical address, and it's also called a layer 2 addresses, right? So many names for the same thing. That comes from the OSI model. This is an industry standard way of describing network communication. The very bottom of this is the physical layer. That's where hubs existed. They were just physical devices that simply repeated signals. The second layer up is known as the data link layer. That's where some intelligence exists beyond just repeating signals. And that's where this address exists. I'll save all of these other layers for when we dive deeper into network communication. The last core function of the switch is to provide power over Ethernet. We live in a world that is often called the Internet of Things, meaning thermostats, video camera, telephones, all kinds of devices connect to our network switches. And the beauty is they found a way to send electricity from that switch to the device so it doesn't have to be plugged into the wall. Not only does that save you on wiring, that also provides a central point of power backup. You can attach a UPS power supply to this switch that has a battery to keep it running if the electricity goes out. Now, if your telephone system is connected to that for the office and the power goes out, the telephone system stays running. Now, all modern switches are ASIC based. That stands for Application Specific Integrated Circuitry. It's a really fancy way to say there are hardware chips inside of there that allow them to see those MAC addresses and actually filter the data just as fast as the wire is transmitting. So if this is 1,000 megabits per second, this guy can blast that full and the switch doesn't slow down the communication at all. It can look at the destination of where that traffic is going and send it on its way with zero delay. It's pretty amazing if you think about it. Last but definitely not least, switches come in unmanaged and managed varieties. Unmanaged means it can provide these functions such as a speedy transport, learning the MAC addresses, and maybe even provide power over Ethernet. But you can't actually configure the device and add features or modify its capabilities. It's plug and play. And that initially may sound good, but it's not. You often want a lot of the features that a managed switch can provide. Things like spanning tree protocol, which detects and stops loops in your network. For example, if you were to take a switch and plug in another switch and then, mistakenly connect a cable like that, you've caused a network loop. When a broadcast message is sent to the network, and they're sent all the time, the switch is going to send it out all the ports, and this one goes down here, it's going to come back here and start looping around the network, and it actually takes down the entire system. Yikes. Maybe you want port security, so you know exactly what devices are plugged in here. Maybe you want to do a port mirror, where you can have a monitoring workstation for auditing or troubleshooting purposes and mirror all of the data coming out those ports so you can see what's going on with the network communication. Or maybe you want to do a lag port. That's known as a link aggregation, where I could connect 2 or 4 or 8 different cables to one server and actually splice them all together so I get increased bandwidth between it. I could do that between 2 switches as well. All of those are features provided by a managed switch, and there are literally thousands more. Now, throughout this series, we've been looking at one type of switch, the stackable switch, which is rack mountable. You actually screw some little rabbit ears onto this guy and mount it into the rack. And they're one of the most common switches that you'll find. These guys typically come in 24-port and 48-port varieties, and most of the time will have SFP modules on the right-hand side. That's where you can buy fiber optic connectors to run your cabling hundreds of meters or even miles or kilometers. That's the beauty of fiber. Long distances, whereas copper cable only goes 100 meters. When you get to larger network environments, you might graduate to a chassis-based switch. The problem with stackable switches is they're one device, one power supply, one set of fans, one management board inside that governs the intelligence of that switch. That's a lot of points of failure. So the chassis-based switches have modules that you can slide in. Like, for example, if you look at this big guy right here and squint your eyes really well, that's a 48-port module of switch ports that was added right there. Above that is maybe some high speed, maybe those are 10 gigabit per second ports. Right there are ports with modules in them. There's all kinds of different blades that you can slide into the chassis-based switch. The beauty of it is you now have dual power supplies, you have dual fan trays, you have dual what's known as supervisor engines, which is the intelligence of the switch. Redundancy, redundancy, redundancy. So if any one component of that switch fails, you have a backup that's running and you can replace that component without taking the switch down. In mission critical networks where downtime isn't an option, these switches are what you want to use. These are death to your network. Personal opinion. Desk or small office switches is when somebody is sitting in their cubicle or in a conference room or in a little copy machine area, and there's the copy machine, and next to it is a little IP phone that they want to get online, and they only have one wall jack that has been run there. So they'll go out and buy one of these guys or pick one of these up from a garage sale or their friend's house, or maybe the IT people buy a stash of these devices and start tossing them all around the network. Just say no. Don't do it. These die all the time. They're poorly constructed, rarely quality tested, and just a bad design. If you've got a common area like a copy machine area and things like that, or a cubicle where you need a couple devices, then You've got the intelligence from this point in the series. Run a couple patch cables to that location. Go direct from the switch to the devices rather than introducing these little travesties into your network. So many issues over the years where these guys fail or somebody just connects a cable like that and causes a loop in the network. The stories I could tell you. One more puzzle piece to discuss and then we'll get to the installation of our switch. The question is to patch or not to patch. There's two different mindsets when you're installing switches. And that is, the number of switch ports that you should have should always match the number of patched cables that you have in your office. The other is just to patch in what you need for the moment. This strategy will cost you more money up front. Likely, this strategy will cost you more money long term. Meaning, let's say that you have a patch panel that's 48 ports like this. In this case, whoever is running this network, actually, it looks like they have 3 switches, has purchased 3 switches. 24 of these cables line up to this guy. 24 of these cables or so, because it looks like they got this little strange one going down here, line up to this guy. And then this one is for the overflow, meaning maybe there's more devices in the rack or cables that aren't directly patched in that they're using on that third overflow switch. The point is there's not a port on that patch panel that is not connected to a network switch. That means you're going to have to buy more switches. But that also means down the road, when you hire Susan or Bob moves offices, it's immediately going to work when you plug it in. This strategy is just patching in what you need. Notice, this switch is maxed out. So when Susan is hired and you go, oh, I've got to plug that one in, you're going to look there and go, oh man, we're out. And you know what usually happens? The network administrator who doesn't have time at that moment to go order another switch will look at the lights and they'll find one that's not blinking because they're going to think, oh, I need to get Susan online now. So looks like nobody's using that one. They'll unplug that one and plug Susan into that port, not knowing they unplugged Jack, who hasn't come into the office today because he's on vacation. And next week, you're just going to cause another issue because Jack's going to come in and the same thing's going to reoccur because the network administrator forgets to buy another switch or even deems it unnecessary because their job every day should be going and swapping in the ones without lights for the ones that need lights. And in the end, you end up costing yourself more time and office unproductivity using this strategy than just buying the number of switches that you need to start off with. Now, you might remember our current network environment, which still looks somewhat pathetic. We've got a 48-port patch panel and a 24-port, well, technically 28-port, switch. Now, all of these ports aren't patched in as of yet, but I know we're at least up to around 40. So if we're going to stick to getting all the cables patched in from the beginning, which saves us money in the long run, we're going to need another switch. Now, ideally, we could get a single 48-port switch for that rack, but unfortunately, budget wouldn't allow it, so we've got a second 24-port switch. Actually, this is a Cisco SG300 28PP. First off, SG300 means it's got a whole bunch of switch capabilities. It's a managed switch. 28 represents the number of ports. PP represents the type of power over Ethernet that it's providing. I received this switch about a month ago, but I've left the seal on it for this very moment. You don't realize how difficult that is for me to do. I'm breaking the seal now. The Cisco switch. Now, right in the back of it, I see a few cables, power cord, and this is known as a console cable. Since this is a managed switch, a lot of times you'll want to be able to configure it, but it isn't manageable yet because it doesn't have an IP address. This console cable allows you to attach a serial port from your laptop to manage the device. I also see in this little box the rack mounts. Cisco realizes not everybody wants to rack mount their switch, so they make these optional, and we'll be screwing those on in just a moment. Rubber feet in case you don't rack mount it. And 2 sets of screws. Little screws to screw on these ears, big screws to mount it in the rack. Let's pull this guy out and get it going. First thing that we'll do is get the bunny ears screwed on. All right, bunny ears are on and I'm back at the rack. First thing I'm going to do is securely mount that patch panel. I didn't screw in the screws all the way because I wasn't sure if that's where it was going to go, but now we're sure. Some people use power drills to put these in. I usually go with the manual screwdriver because I've stripped out so many of these, and pulling them out at that point is no fun at all. There we go. Good, solid. Now I'm going to skip the space of these 2U because I've already purchased this 2U horizontal cable manager. That's coming in the next nugget. For now, I'm just going to leave the gap for when we get that installed. Here's our existing switch. It's the same model as the one that I purchased, and I'm looking at the holes on the bunny ears right at the top, right at the bottom. So I'm going to put our cage nuts into this U right here. Top and bottom. Top and bottom. Now I'll lift this up and screw it in. This is where IT people get a workout. I'm using the screws that came with the rack, not the ones that came with the switch. There you go, that should hold it. And tighten them down. Good. Right below it will be switch number 2. Squeeze that guy in there. There we go. In some racks, if you drop a screw like that, you're doomed. It's falling into a pile of equipment and you'll never find it again. There we go. I'm not even going to power this switch on until we get proper cable management installed. Our network switch is installed. Now, I promised at the beginning of this nugget that you would understand the core switch functions, switch selection, and installation process. Now it's time to do it. First off, research what switch options are available to you. Go on a Google search that dreams are made of, finding switch key features, form factors, and pricing. Then put together a price list for the top 3 options you would want for your ideal environment, or if you don't have an ideal environment, find a small, medium, and large switch that fits your imaginary campus. From there, we go practical. Determine which switch model you would like to use for your home or office environment. Be sure to plan for PoE support. Power over Ethernet adds quite a bit to the price tag of the switch, and you may not think you need it right now, but if you buy a switch without it, and then in a year end up adding devices that do need it, you have to replace the whole switch. There's no option to add PoE to one that doesn't have it. So think ahead of the places you'll go. From there, purchase and install the network switch, connecting all the needed cables from the patch panel. And finally, test connectivity in the network environment. At this point in the series, seeing the green light come on the switch for devices that you have plugged in is good enough. We'll start getting to the IP addressing and internet access later on. I hope this has been informative for you, and I'd like to thank you for viewing.